Hi, everybody. This is Mr. Folly, and welcome to, I don't know where we are. There's somewhere around the 1.5-ish kind of thing. So let's take a look at ionization energy and so on and so forth, and some Coulomb's law stuff. So ionization energy is energy to remove a valence electron from a gaseous atom. The chemical reaction is this. This is a most missed question on the test. If I say write the equation of what happens for ionization energy, so I have an element, and then I have an element with an electron on here. Oops, this should have a positive on there. So it should be X positive plus an electron, okay? Ionization diagram. So here's the diagram. Oops. So I'm trying to remove a valence or outermost electron, okay? Ionization energy determined by the size and nuclear attraction, which is also called Coulomb's law, okay? So this is the force of attraction. I often show it as bond energy because it's the bond energy of the electrons for the nucleus. And there's some constant K. Q's are charges. And R is radius, which is really distance. So smaller atoms have a larger ionization energy because they are closer. Oh, and that's the divided by radius squared. More positive nuclei, greater number of attractive protons, have a larger ionization energy. So that means if there's a greater attraction, then it will have a greater ionization energy. It takes more energy. Okay, so now let's talk about some charged particles. Charged particles and isoelectronic. Isoelectronic means it has the same electron configuration, but it's still the same atom. And we talked about this a little bit, how K positive is not argon, but it has the same K positive, same electron configuration. So K is 19, argon is 18, and that's why the +1 does that. Okay. Ions are isoelectronic or isoelectric because positive ions lose electrons, negative ions gain electrons, and we can get those charges in the periodic table. So those charges would be everything in this column is +1, everything here is +2, +3, 0, -3, -2, -1, 0. Okay, so if you gain or lose one, you're going to do this. So most often they are isoelectronic with a noble gas. And the noble gases are these blue ones right there. Okay. All right. So examples, calcium +2. So calcium is, from what we did before, is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2. Now that's calcium. Calcium +2, lose 2 valence. So that means I'm just going to chop that off. And I'll have 1s2, 2s2, 2p6, 3s2, 3p6, which is the exact same thing as argon. Okay. F-1 is nearly the same thing. 1s2, 2s2, 2p5 is fluorine. F negative, I'd have to add 1. 1s2, 2s2, 2p6, which would be the same as neon. It wouldn't become neon, but have the same electron configuration. Okay. Negative ions, their name ends in "ide." So, for example, this is fluoride. And the positive ion is just called ion, so it would be the calcium ion because it's positive. So Mg +2 is magnesium ion. O -2 is oxide, not oxygen. And that's it. All right, so excited electron configurations. So electrons are out of order. That's how we identify it. Usually the last one jumps up, but it could be any electron. They can jump to any spot. You identify them by being out of order. So 1s2, you'd expect it to be 2s1, but you have 3d1, so that's a jump. So anytime it's out of order, it's excited, and it's often shown as element star. And that's it, 5 minutes. How great is that? Toodles, glad you were here because remember, without you, there is no us.